Today we're going to be talking about how to find the distance between a point and a line, and in this particular problem we've been given the point 4, 1, negative 2, and we've been given a line defined by parametric equations. So the first thing we need to do is take the equation of the line, which is in parametric form here, and define it in terms of vectors. And the way that we're going to do that is by treating each of these parametric equations as the coefficients on a vector that includes I, j, and k. So here's what that looks like. We just take the parametric equation here for x, which is 1 plus t, and we call 1 plus t the coefficient on our I component here. We call 3 minus 2t the coefficient on our j component, so 3 minus 2t the coefficient on j, and we call 4 minus 3t the coefficient on k. What this is going to allow us to do is find the direction numbers of this line and also find a point that the line passes through. So in order to do that, what we're going to do is reorganize our terms a little bit. So let's go ahead and distribute each of these values. We're going to get 1i plus ti, then we're going to get plus 3j minus 2tj, then we'll get plus 4k minus 3tk when we distribute each of these values. We're going to put all of our t values together and all of our terms that don't involve t together. So when we do that, we'll get 1i plus 3j plus 4k, like that. That takes care of all of the terms that don't involve t, this one, and this one. Notice that our three remaining terms involve t, so we're going to get plus ti minus 2tj minus 3tk. Once we've grouped our terms together like this, all we want to do is factor out a t from this second group. Notice that each of these terms involves a t. We can pull that out in front, and what we're left with is just I minus 2j minus 3k, like this. The cool thing about putting the equation of the line in this form is that the coefficients in this second group give us our direction numbers. The coefficients in this first group give us a point through which the line passes. So what we know now about our line is that the direction numbers for the line are 1, negative 2, negative 3. And again, we just pulled those from the coefficients in this second group here, right? 1, negative 2 when we include the sign there, and negative 3 when we include the sign. So those are our direction numbers. We'll call these direction numbers here. We want a point through which the line passes, so we'll have a coordinate point here, and we're just going to take the coefficients on these terms here, 1, positive 3, and positive 4, like this. So our point, we know our line passes through the point 1, 3, 4. So this is going to be really helpful information for us. All we need now is a vector that represents the distance between this coordinate point and this point which lies on the line. Remember, we're looking for the distance between the point and the line. This is our point. This is a point on the line. So if we get a vector that represents these two, that's going to get us closer to finding the distance between the point and the line. So in order to do that, first of all, let's call this vector right here vector A. Now we're going to go find vector B, which is going to give us a vector between these two coordinate points here. So we're going to say vector B is going to be equal to, here's where we take our x components and subtract them from each other. So we're going to say our x component right here, which is 4. We're going to subtract from that the x component in this point, which is 1. Then we're going to do the same thing with our y values. We're going to have 1 minus 3, so 1 minus 3. And then for our z values, negative 2 minus 4. So negative 2 minus 4, like this. And when we simplify, you can see we get a vector 3, negative 2, negative 6. Now we really have everything we need in order to find the distance between the point and the line. The distance formula we're going to use, we're going to call it distance, d for distance, is going to be equal to the magnitude of the cross product of a and b divided by the magnitude of a. That'll be the formula we use. This is going to give us the distance between the point and the line, given that we had the vectors a and b, which we already found. So the first thing we want to do is find the cross product of a and b. The cross product of a and b is going to be equal to our typical 3 by 3 matrix here that we use when we do the cross product. So we're going to have I, j, and k. And then we're going to put in here the vector A, 1, negative 2, negative 3, and then the vector B, 3, negative 2, negative 6. Now, in order to break this down, remember that we take everything outside of i's row and column. So we do -2, -3, -2, -6 multiplied by I. Then we subtract, because remember we have positive, negative, positive orientation here for I, j, and k respectively. So we subtract our term for j, do everything outside j's row and column, so 1, -3, 3, -6 times j. Then we add to that everything outside k's row and column, so 1, -2, 3, -2 times k. Now, in order to simplify here, what we'll do is multiply the upper left and lower right, so -2 times -6 is a positive 12, and then subtract the product of the lower left and upper right. -2 times -3 is a positive 6, so we subtract that positive 6 times I. Then here for j, 1 times -6 is a -6, minus 3 times the -3 is a -9 multiplied by j. And then we add to that here for k, 1 times a -2 is a -2, minus 3 times a -2 is a -6 multiplied by k. When we simplify, 12 minus 6 gives us 6i. -6 minus a -9 is -6 plus 9, which is going to give us a positive 3. But we have this minus sign out in front here, so we're going to say minus 3j. And then -2 minus a -6 is -2 plus 6, which is a positive 4, so we get plus 4k. Now this vector just becomes, when we take the coefficients, 6, -3, positive 4. Now remember, that's just our cross product. What we're looking for is the magnitude or the length of this cross product value. So in order to find this entire numerator here, the magnitude of a and b, that's what these bars here tell us, the magnitude of a and b, what we need to do is find the length of this vector. All we do is take our component values, square them, add all of those squares together, and take the square root. So here's what that looks like. We'll say the magnitude of our cross product is going to be the square root of, and here's where we just square each of our component values. 6 squared is 36. Then we add to that -3 squared. -3 squared is a positive 9, so we say 9. And then we add to that 4 squared. 4 squared is 16, so we add to that 16 like this. And what we get here is 61, so we get the square root of 61 like this. That's our numerator here, the result here, for our numerator for the distance formula. Now all we need is the magnitude of a itself, and we already know how to do that. We take the square root of the squares of our component values here, but now we need to do that just for the vector a. Well, remember the vector a is these component values 1, -2, -3. So to get the magnitude of a, we're going to do the square root of the squares of each one of these. So 1 squared is 1, plus -2 squared is 4, plus -3 squared is 9. So we do that, and we take the square root. When we add these together, we get the square root of 14. This is going to become now our denominator. So what we know is that our final answer for the distance between the point and the line is, we'll call it d for distance. D is equal to square root 61 divided by square root 14. We can simplify that, and we'll write our final answer here, but say d is equal to square root of 61 over 14, like this. And that's how you find the distance between a point and a line given this coordinate point and the line in the form of parametric equations.